Right, great tens, you ready for things that are more complex? More complex? Yes, let's make it more complex. Okay, so of course, we'll make it maths as we go, and we got two lovely examples to work through, and here we go. Determine the solution of 2 cos 2 theta minus 30 equals negative square root 3. For theta between negative 360 and 360. Okay, does that seems pretty good? And sorry, I just need to take this. No, they are excited. No, they are. That's okay. Okay, sure. Okay, so sorry, I was just checking in if you are excited, and it turns out that you are. So here we go. Determine. So I'm going to run through it. With less explanation. Imagine that, and quicker. And you're already a minute in. You're going, this isn't possible. But then Friday's one, because we've got that kind of depth to draw on. And now we can go through speeding up our process or just developing our process, our procedural. So let's have a look here. We've got this. I'm going to rewrite it because I kind of want to just see it here. Minus 30 degrees equals negative square root 3. Okay, so first step that we need to do for our equation. Well, what is it? Okay, well, we want to divide both sides by 2. So divide by 2 and divide by 2. At least we've got cos, and this negative square root 3 looks a little bit more like that. Okay, so there we go. We've got cos, and then next step. Well, next step we find our reference angle, and we go shift cos of that doodah there. So let's say that doodah. Oh, no, maybe enough for the dramatic zooms, but come on, they are goody. So, and we take it of the positive, remember, of that to get our reference angle. And you remember your special triangle, of course, and you nod your head and you smile and you go, sure, I had made this thing materialize. And I was like, well, I just went shift cos, which is actually r cos, but anyway, shift cos of the square root of 3. And if you did know your special triangle, now you can kind of go, yeah, no, I got that a lot quicker than typing it in, or it didn't take too long anyways. So you got 30 degrees as your reference angle. Now, what we work with our reference angle is that means that this part here equals our reference angle. Well, sort of. Remember, we've got our beloved cast diagram. What does our cast diagram help us to determine? Well, cast diagram helps us figure out what's positive and negative, right? So CAST in this case, well, I shouldn't look at that equation. I should look at this one. Cos is negative, so therefore I know that we're dealing in these two quadrants, and therefore our two solutions are there and, well, I guess I could do it vaguely to scale. So there and there. So our reference angle was sitting over here at 30 degrees. And so our two solutions, now that those two solutions relate to 2 theta minus 30. So 2 theta minus 30 is, we should have an or here somewhere. I don't know where to put my or. Is going to equal, well, what's option 1 in the second quadrant? Well, if that's 30 over there, then that's 150 degrees. What's option 2 here in the third quadrant? Well, if that's 30 degrees, then we're on 180 plus, and that gives us 210 degrees. Okay, so that's kind of our rhythm and our routine. They're the two options. But this graph, the graph of cos theta, repeats itself every 360 degrees. So plus 360k, plus 360k. I'm going to come back to the period of this 2 theta in a second. And now we've just got two nice equations that we solve. Add 30 to both sides. 2 theta equals 180 degrees plus 360k. Just think we're adding to the constants, not to the variables, like terms. And so theta equals, divide both sides of the equation by 2. And there's our one option for theta. And we solve our second equation in the same way. Add 30 degrees to 40 degrees plus 360k. And therefore, divide both sides by 2. And we get 120 plus 180k. So there are two solutions that are highlighted in yellow. Now I would say I'd come back to that question about period. looking at this graph here, cos 2 theta minus 30, what is the effect of the 2? And therefore, what is the period of that graph? Okay, the effect of the 2 is that everything happens twice as quickly, therefore our period is 180 degrees. So therefore, we're going to have a new solution every 180 degrees. So that's the link to that 180 degrees over there. So if you wanted to, and I'm going to leave you to do this, but if you wanted to, you could draw what this graph looks like. It's happening twice as quickly, and it's moved right by 30 degrees. Well, right that way. Okay, so I'm going to leave you to do that, because as I said, today I just wanted to focus on, solving the equation, getting there a little bit quicker procedurally, but planted the seeds enough for you to make those conceptual links, but especially for those that were struggling a bit more with Friday's work. So now we've got our two answers in general, our general solution. And it says that we only care about answers where theta is between negative 360 and 360. So I'm going to copy that and have it down here for reference. And so there we should have everything in frame with that just above my head, right? Okay, so let's have a look here. It's above, it's like a floating balloon. So it makes me want to let me just get some helium here.
And there it is over there. What do you think of the negative 360 to 360? It's too much helium.
Okay, so now that we're vaguely back to some normality, we've got our two solutions and theta must be in that range. So we can look at all of our options. Now, I must be honest, I don't know what the most efficient way of doing this is. I generally look at this one and I go, well, 90 is one option there, and this one's option was 120. We got our period of 180, so from 90, we can add 180 to it. Well, that will give us 270, I think. And for the 120, we can add 180 and we'll have 300. And you start just spotting things like, oh, these are 30 degrees apart, so these are obviously going to be 30 degrees apart. These are 180 apart. And if you go another 180, you're going to be outside of this range. And then it's always weird to say range because that's a domain. And, you can go back by 180. So 120 minus 180 is minus 60, I think. I wish that we're doing this on the board so you could correct me. But it's so intimidating doing it here on video. I'm like, sure, I'm making plenty of mistakes. And then we said they were 30 degrees apart. So that should be minus 90 by that logic. And 90 minus 180 is minus 90. And we can probably keep going because minus 60 or negative 60 minus 180 gives us minus 240, right? I'm hoping this is where I get nervous and I just get this little cheat up and go, so I think we're on like minus 60 and then we're subtracting 180 and I definitely could do that in my head. Anyway, so minus 90, we subtract 180 and well, that's negative 270 and I'm starting to run out of space. But I think that we should almost be done because negative 240 minus another 180 and we've gone too far backwards, right? Let's just, what does our calculator say? Just minus 240 minus 180. Definitely, right? 420. Okay, cool. So there's our first example. Kind of get our logic. As I said, I'll leave you for this one. I'm not going to draw the graph. I'm not even going to throw it up in GeoGebra or anything. We can look through that in class if you want to. So second example, because now when we've got our kind of nice, I forgot that did that. When we've got our nice way of, we've got a nice procedural way of doing this, now everything can just flow and we can go through this quite procedurally, quite quickly. But in the back of our minds, I hope that we're thinking a little bit of the conceptual, right? So I think go for it. Or do you need more like go for it? Do I need to like go for it?
Go for it.
Okay, so maybe you've gone for it now. So here we've got our thing and we've got divide both sides by 3. So we've got tan 3 theta plus 45 degrees equals 4 over 3. Maybe one thing just before we go into this, just in case, and that is just think about our asymptotes and where tan theta, I'm just going to call it tan x, think where this is undefined, just in case that comes up as one of our answers says like, well, in terms of this, x equals 90 degrees, and we'd have to disregard it because that doesn't really work. Now, I don't think that's going to come up here, is it? But, just back of your mind, you've got that thinking. Okay, so again, I'm going to run through this quite procedurally. In fact, before we go through that, maybe a question so we can blind to it. What is the period of this tan graph that's given? Well, the period of tan x, as it would normally be, repeats itself every 180 degrees. This is 3 theta, so it's going to repeat itself every 60 degrees. So we expect in our general solution to have plus 60k sitting there somewhere, right? So that's where we might go to. So let's do this though. We're going, okay, well, first of all, we get our reference angle and we go, the shift tan of 4 over, where's my undo? 4 over 3, and we go along there, and we go there it is, and we go shift tan of 4 over 3, zoop, bloop, bloop, 53, comma, I'm sure you've seen that 53. Do you start recognizing the 3, 4, 5 triangle and the 53 degrees yet? Okay, maybe not, but maybe you start seeing that 4, 3, and, well, that's 53 there, the 4 over 3, right? I don't know. So 53, it is positive. So we know that we've got our little cast diagram. Maybe I can sneak it in over here. And we've got CAST. So we know that we're in this quadrant. So we got our 53 as our one option. So 3 theta plus 45 equals 53 degrees plus 180k, because tan repeats itself every 180, or 3 theta plus 45 degrees equals, and now we look down here and we got 180 plus 53, and that gives us 233. I think, is it close enough? 180 plus 53. Whew, okay, thank goodness. 233, right? Let's look at the calculator up here. It would be awkward if I just pretended let me just think about that. Plus 180k. Okay, and here's where we see that dividing by 3 to get our period change. So run through it, and just maybe now that you've had 2 examples, and so at this stage, before I show the final steps to this question, how are you feeling on this, particularly maybe, so either just I'm fine, or still working on it, or maybe a more in-depth opportunity for feedback here for, how's this starting to gel, these general solutions, particularly from Friday, and the conceptual and procedural links and that. So up to you if you want a short little answer or just an opportunity to give a little bit more feedback. Okay, so I'm certainly interested to see what comes out of that. So here we can go 3 theta equals subtract 45. So we go, wait for it, with the beloved calculator, minus 45, 8. I know, slow maths today. Plus 180k. So theta equals 8 over 3. I don't know if it's worthwhile doing it as a decimal. We're probably going to do it as a decimal anyway. So, we go 8 over 3, either S to D it or shift that button is quite nice. 2 2/3. I kind of like that version sometimes. So 2 2/3 plus, 60k. That's why I like the idea of kind of having thought through this 60k that I'm circling behind here. This 60k, I've already thought about that period, so I'm going to catch myself not dividing there by mistake. Okay, and then for here, 3 theta equals, and again, let's just go for it. 233 minus 45, 188, plus 180k, theta equals 60 whatever, right? Divided by 3, shift that one 62 and 2/3. And I like it like that because we still got it in a nice fraction format, but at least we got a sense of 62 and 2/3. Like that one, I don't know where we are. Okay, so shift that there. Yeah, I'm going, oh no, I don't have it there. Yeah, I'm just going with the shift button, shift fraction button is quite handy. Plus 60k. So we've got our two general solutions for theta. And I don't know why the question doesn't stop there. It feels like an unnecessary step, but anyway, to go, okay, so we're looking at all our answers between negative 180 and 180. I guess it makes sense. So between negative 180 and 180. So again, do you have a better strategy than jotting down these two kind of in the middle and then working out your other ones, or how does that one work for you? Okay, well, let's say that you did that plus 60, and therefore we know that plus 60. Wait a second. We've got our same answer here, don't we? Did I just... Oh, I've lost my mind. Why did I lose my mind? Why are these two things... I'm going to leave this because this is a good question now. Why are these two things exactly the same? And did you spot this? Maybe you've written something already. Why are those two things? I'm going to put a big A and a B. Why are those two things the same? Why should I not have bothered wasting my time over here with that? And therefore, yeah, just a big why. Write down your grumbles. Write down your grumbles with me now, please. Okay, maybe you put them down earlier. And I must be honest, just out of interest, why I made this little mistake was because another way of kind of working through this is that you forget that the period is 180 and you just go plus 360 and you find your two solutions in the Cartesian plane. It's not a great way. It's okay to do it. I do it with other classes, but okay. So we got 2 and 2/3, and we're just adding 60 all the time. I can't believe I only spotted it now. And we've got 62 and 2/3. My goodness. Okay, and we're gonna add 60 to that, and we're gonna get 122 and 2/3. And if we add another 60, we're gonna go too far. So we're gonna go 2. Now, just as a matter of interest, because people sometimes do this, if I write 2 and then, wait, I do this. I write 2/3 and then I write 2 over here. Why am I going to get 4/3 as my answer? How should I use my calculator better? Okay, so there's 4/3, which is clearly wrong. And the reason is I need to go shift that to go 2 and 2/3. Now it gives me the 8/3 or the 2 and 2/3. Maybe useful just to get that. So minus 60 equals minus 57 1/3. I know that we could have done that without the calculator, but I'm feeling the use of my calculator today. I want to get my money's worth. Minus 117 and 1/3. Whoopsie, because now we're in the negative side, so that makes sense. And 1/3. And if we subtract 60, we should still be going fine. Minus 177 and 1/3. These are all, of course, in degrees. And that's that. Okay. We got there. I don't know. So much for quick and simple, right? We kept under 20 minutes. Let's quickly go and make it maths. Okay. Goodbye.